3.2 linear programming graphical method. Example 1 says graph each system of inequalities, label the corners. So we're going to have some kind of region. A lot of the times it's a triangle shape, but maybe not. I don't know. We'll see. When I see this first inequality, x plus y is greater than or equal 5, I know a lot of students are tempted to put it in slope-intercept form, and you can if you want to. But I like to use what I call the intercepts method or the cover-up method. Basically, the thought is I need 2 points to make a line, okay? So if you look at it like this, and if you plug in 0 for x, okay, that goes away, and y would equal 5, correct? Can everybody see that pretty quickly? I can do this really quickly in my head, and I can see that the y-intercept is 5. And likewise, I could plug in 0 for y, and the y goes away, and I can see the x-intercept is 5. Okay, so I like the intercepts method because I can do it pretty quickly in my head, and I don't even need to write down that table. I will the first time, but I probably won't next time. Okay, so what I'm saying is the x-intercept is 5, so I go over 1, 2, 3, 4, 5 and put a dot there. And the y-intercept is at 5, and so I go up 1, 2, 3, 4, 5 and put a dot there. So if I can draw a line, I'm going to have a hard time drawing a line through, but if I can draw a line through there, I've got it. Oh, that's terrible. I don't know if I'm going to be able to do this. Maybe I'll zoom a little bit. Okay. Do your best. Use a straight edge if you need to. This is really hard, okay? So then the next one, x is less than or equal 7. Just go over 7. That's a vertical line. We already know that. 1, 2, 3, 4, 5, 6, 7. Vertical line. Right there. And then y is less than or equal 8. That's a horizontal line. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now we need to think about the shading. Okay. Typically what happens is when you see a greater than like this, when you see y greater than, that means to shade up. So we would be shading up from the diagonal line. When you see an x is less than, like right here, that would be to shade left. So we would be going left from the vertical line. And y is less than tells me to shade down. So I'm down from the horizontal line. So you can see in this case, they're trying to get me to shade inside that triangle. So color that in, do a nice job, make it look nice. Ugh. Okay, you can probably do a better job with me or than I can. That's what's called the feasible region. Okay, once we start solving problems, okay, linear programming, we're trying to optimize, we're trying to find the best, the least, the maximum profit, the minimum cost. We're trying to do something with this, but that's called the feasible region because any solution to the system would have to be in that triangle there, all right? But we're going to learn something called the method of corners. And so essentially what we need to do is look at the corners of those, of that triangle. Okay. So you really want to be neat about this because you have to tell me what the corners are. Okay. And so I don't think I've done a neat enough job because I can tell this one's in the wrong place. All right. But let's see. This one right here. Tell me what you got on your graph. What is that point? What are the coordinates? 7, -2. Good. 7, -2. Mine doesn't look so hot. What about this one up here? Should be 7, 8, right? Should be 7, 8. Okay. And then that one on the left side, I think mine's graphed wrong because I had such a hard time drawing that diagonal line. But I believe the point should be negative 3, comma 8. Is that what you got? Negative 3, 8. So I might have to go back and redraw that. But anyway, that's what we're trying to do. If you can get there, if you can get those corners, then the rest of it's just basically plug and chug. Okay? Let's move on. Part B. I'm going to look at those intercepts. And the x-intercept, I would cover up the y, and the y is gone. X has to be 8. So I know 1, 2, 3, 4, 5, 6, 7, 8. There's going to be a dot right there at 8. Okay? And the y-intercept for that top line, I would cover up the x, leaving me 2y equals 8, so y's got to be 4. So I go 1, 2, 3, 4. That's the intercepts method. All I'm thinking here is I got to get 2 points. If I can get 2 points, I've got my line. Okay? If you don't understand the intercepts method, you can always solve for y and put it in slope-intercept form. I think this is easier most of the time. Okay? Most of the time. So I've got to draw a line through. And you want to be as neat as possible. If you want to use the slope and go up, you know what, go up 4 and left 8 and give me another dot, maybe that makes it a neater line, but just do your best, draw it as neat as possible. Use a straight edge if you need to. The next one says y is less than or equal 1/2 x. And if you want to think of it as 1/2 x plus 0, be my guest. That's a 0. Start at 0 and go up 1 and over 2 and up 1 and over 2 and up 1 and over 2 as many times as you want. You really only need 2 dots, okay? But you do need to draw a pretty good line through there. Like so. Okay? And then the last one says y is greater than or equal 0. And so that's, of course, a horizontal line through 0 on the y-axis. So basically, you're tracing the x-axis right there. Okay? Now, think about the shading. Typically, when you see y is less than, it's going to mean shade down. So that first line I drew, I'm going to shade down from that. And then we've got another y is less than, so we're going to go down from the second one. So both diagonals, I'm going down. But then the third one says y is greater than or equal. I know I'm going to shade up. So if I'm down from the first two and up from the third one, that's putting me inside the triangle. You will not always shade inside the triangle, okay, or inside whatever the shape is. Sometimes it's a quadrilateral, okay? You will not always shade inside there. You have to pay attention, okay? I think most of the time it's pretty straightforward, except when there's a negative sign. When they throw negatives at you, sometimes you have to flip. Remember when we deal with inequalities, when you divide by a negative and you have to flip the inequality symbol? That comes into play sometimes when there are negatives, but I don't see any here. Okay, so the last part is let's label the corners. So we've got a corner here at 0, 0. And a corner here at, what is that point, 8, 0. And then this one, you know, hopefully you did a neat graph. Hopefully you counted carefully. Looks like the point 4, 2. So what's going to happen, what makes some of these hard, is they won't always be right on a tick mark, okay? Maybe you graphed it crooked, or maybe it just doesn't happen to fall on a tick mark, okay? That's where I would use Desmos. Optimize to find the maximum or the minimum value. If an optimum value exists, it is at a corner point of the feasible region. Notice the word if implies sometimes there won't be a maximum or a minimum. Okay. But if there is one, it's going to be at a corner point of the feasible region. The feasible region is just what I shaded. A lot of times it's a triangle or a quadrilateral or something. Not necessarily, though. It doesn't have to be a nice shape. It might be something weird or something unbounded that goes on for infinity. Linear programming optimized using the method of corners. Okay, so the method of corners is what we're calling it just because we need to find the corners of that region. And basically what we're going to do is plug them in. So write the objective function and all the necessary constraints. That's just the problem. Graph the feasible region. That means graph the lines and shade it. Identify the corner points. And then number 4 is the big one. Find the value of the objective function at each corner point. That basically just means plug in. Plug in the corners. After you get there, it's just a matter of which number is the biggest. Okay. If I want to find the maximum, I look for the biggest number. If I want to find the minimum, I look for the smallest number.